Okay, so let's start. So, hello everyone. My name is Milovann. I am an architect and an associate professor in computational design in France. And yes, today I'm thrilled to introduce GitAec. It's a prototype of a new kind of BIM platform, let's say this. Yeah, it was started last year at the hackathon, the Zurich Hackathon. So I'm really delighted to be there again. And I thank all the organizers, opensource.construction. And yes, so I will talk about IFC versioning, but you'll see that I will try really to go deeper in the base concepts of all BIM platforms and versioning. You'll see that, okay? So yeah, let's start and try to start with this basic idea and try to describe what is GitAec. And in short, we can say that GitAec is GitHub with GitAec extensions, okay? So you'll see, I'm going step by step into this, describing this platform and the possibilities, but let's start with the basic idea that, okay, GitAec is a CDE, okay? Let's start with this simple fact. It's a common data environment. Well, it's a prototype. But you'll see that I want to show you step by step that it may be a new kind of CDE, maybe more a common development environment. And why not, yeah, a computational design environment more broadly. Okay? So, yeah, so talking about computational design, just to introduce and give some context, I will show two examples on how I start using Python and Blender in the context of AEC, and to illustrate how we have moved from the desktop era to the cloud era. Okay, so let's start by this first example. This was a project I was involved in, the competition I was working in Paris, and this was back in 2006. Yeah, at this time there was no Grasshopper, you know. So for this project, at some point we needed some parametric object to make some kind of parametric envelope, and this was the start for me personally to use Python within Blender to add these new functionalities. I don't go into the details, but yes, that was really for me the starting point of coding for AEC with Python in Blender. So yes, this is the first way you can code in AEC is by using an API, a Python API in the case of Blender, and extending an actual software. Okay, so this is the first kind of thing you can do. But yeah, and the second example I want to discuss to introduce this platform is more recently for my course in the university, I developed a serious game for teaching computational design, and it was still using Blender, but as some kind of game engine an engine, a headless Blender on the server. So I start using Blender with Python again, but more recently I had the idea to bring the game online and to make an online platform with this serious game made on Blender. And so, yeah, that was the starting point of GitAec by simply using an open source project, which the name is Forgero, which is an open source clone of GitHub. And yeah, basically I assembled this platform with Blender, headless Blender, only using it as an engine for testing files and for making a virtual world for the students. So yeah, so this is the second way you can code in AEC is by, today it's more about connecting applications. As you know, this is really the main topic here on all these talks. So, and to just describe this, it's interesting to see there are really two types of APIs. You have the application API, and today we are more dealing with web API to connect the software, to connect the data. So yeah, so just to make quickly the idea that we extend from the desktop era where we have files and software, and then we connect through the network. And today we clearly are on this cloud moment where we have to connect all this technology together. So to continue, I want to introduce something, a concept very important for me, and I imagine for us in AEC, is what I described as the flow-based modeling approach. That I get inspiration from the flow-based programming patterns of programming, which states that when you develop complex applications, you should treat your application as a graph. This graph is very similar to what you have in a visual programming interfaces like Grasshopper. And particularly with this flow-based programming, it states that you should concentrate on the edges of this graph rather than on the nodes where the computation actually occurs, because really the logic, the intelligence of your application relies on the connections between these nodes. So just treat the nodes as mere black boxes that in some way are interchangeable. Okay, this is the flow-based modeling approach. So how do you technically do this today? How do you connect all these softwares? Well, there is here again a very popular way of doing this. The name is port and adapters. The idea basically is to have a central model, a kernel, where you will develop all the primitives that you will use, starting with the vectors, the meshes, but after all the slabs, the walls, etc. So you have a central kernel which holds all your primitives, and then there is this port and adapter where you will use APIs, application APIs on the side of all your softwares to have some kind of translation units to translate the data from one software to the other, going through these ports and adapters. And then you have the data flowing from one app to a second app. Okay, so this is the port and adapters, and the other name is hexagonal architecture. Okay, so I think that now you basically understand where I'm heading to. Practically, how do you do that? You can use Speckle to connect one application with another. But you can also use BOM to do that. How many of you know BOM? Because I really see that BOM is really well known, not well known, so you should really go into knowing more BOM. I will talk a bit later on. So you can do it with Speckle, you have BOM, but you have also Compass, and you can see that clearly all these frameworks, they are on this logic of the flow-based modeling, where you have to connect all these resources, these data, this software, to work together. So coming to the idea of versioning, why am I talking about all these frameworks and the flow-based modeling approach? Well, let's start with Speckle to talk about this. So just for, if you don't know what is versioning, versioning is using something like Git, which is very popular, to have some kind of history of all your modifications. So this is what we are talking about versioning. And what's really interesting is when you look at Speckle, you see that one of the main features of Speckle is versioning control, and you see that Speckle presents itself as the Git and the hub of geometrical data. I don't go too much into details, but this is one of the first type of versioning you can do with Speckle, which is on the server side, and it's stored as a graph of objects. And now I want to show you a second type of versioning with GitAec, and using the IFC merge project from the OS Arch community. So now I will show you very briefly what is GitAec. So as I said, GitAec is some kind of clone of GitHub, and the first extension is having a viewer for IFC files. So it's basically a repo with an IFC file. You can click on it and open the viewer. This viewer is made with the open IFC.js, that open company today. And what's interesting now to show you is that, it's not here, and to see what is versioning, speaking about IFC files. This is really interesting because this file, this sample file, has been made by many different actors, many different people involved, And we can see here all the commits, all the modifications of these single files with different modelers. And I can select whatever moment in the history of this modification. You see here the IFC file, how it has changed over time. And I can browse the file at this moment and look and see how it looks like at this moment. And you'll see that, yes, here we see that the file this is the same file, but seen in another time moment and in time, okay? So yeah, this is what it is about IFC versioning, another way of doing versioning in AEC. And I want to continue with a third way of doing versioning in AEC. It's related to this BOM framework to do a flow-based modeling. What is BOM? BOM is a flow-based modeling framework. It's made by engineers. That's the really interesting thing about BOM. It's made by engineers, the Bureau Happold engineers, and it's both being developed by these engineers and used at the same time on real projects. So what's interesting here is to see that when you're working that way, meaning you're developing your kernel, you're developing your flow-based framework, and at the same time you're using it on real project, on files, you can imagine that these are different teams, and so that all these files are diverging in time. So there are conflicts emerging. So that's why the versioning of both the framework and the software you use and the plugins and the ports and adapters, you have to deal with the version of this. So this is really a third kind of doing versions, is having the version of the source code and the files involved in making these complex workflows. So yeah, three way of doing versioning. The first one with Speckle, graph-based in-memory style, and the second one is linked to file-based with the IFC files, and the third one, code-based with BOM. And what I want to say more clearly now is that maybe it's time now to clearly see that there is in this schema, this big schema of the flowing of data, that there is really two different ends of this process, which are really not the same. You have the upstream and the downstream of this flow, and generally we are really speaking about the downstream part of this flow, when the data has been generated by a modeler in the software, or by a script, or maybe by an agent today, AI agent. But really now we see with BOM that when you're both developing the code and using with data, you both have to have this in synchronization. So it's important now to see this direction of the flow and have a clear understanding where am I in the upstream or the downstream part of this flow. So to get to the conclusion step by step, let me finish with an analogy with the cloud engineers. When you're dealing with lots of servers, you don't do manually specify how the server looks like, how do you connect the servers. You use what the cloud engineer speak about infrastructure as code. You just use a more intelligent way of doing this by code. You specify by a code that you will then execute to have the actual states of your server. So I propose that maybe we should start speaking in AEC of architecture as code, to have clearly in mind this idea that there is an upstream where we have functions that will generate data, and so architecture as code with both the code and the data. That's the main idea. And when you want to deal with both the data and the code, well, this is exactly what we call a forge. GitHub is a forge. This is a web app where you have both the code and a function that you can execute to generate new data and to automate jobs. Okay, so that's it with GitAec. It's just an early project with some kind of GitHub for AEC. I hope you enjoy it, and yeah, I think I'm done with my presentation. So thank you very much.